This is my existing vertical blind control that I have in my study, which I made many years ago, and which is what I want to update next. As you can see, it's pretty damn ugly, but it does the job. It's based on an Arduino Uno. And the way it works is I've got two stepper motors driving pulleys on each of the two cords. One rotates the slat and the other opens and closes them. From a control point of view, I use 3 light dependent resistors set in tubes and set at different angles so they detect the brightness, if you like, from the sun, and then it will rotate the slats so that they turn and keep the really bright sunlight out. But as things are, the slats have only got 4 positions. They're either fully closed, or they are fully open, or they're at 45 degrees left or 45 degrees right. I spend quite a lot of time in my study and I like to have as much natural daylight as possible. So the criteria I use is that the blind should be open as much as possible to let as much light in, but at the same time, when the sun's really bright, then it can I can't see my computer screens and it gets in my eyes, so I need to rotate the slats to stop that. I'm currently using end stops and I'm going to retain those. I've got one on the track and one on the little ferrule thing that for the cord that rotates the blinds. But the existing controller is very noisy, and it's also very slow. So the new prototype that I've got is going to run on an ESP32, so I can integrate that with Home Assistant. And it also uses TMC2208 stepper motor drivers, which are pretty much silent. I can also drive the motors a bit faster as well. So this new prototype is going to use homing switches, the same as this, so I can set the position of the blinds, and then I can rotate them or open or close them in relation to those homing switches. But instead of using light dependent resistors to get the angle of the sun, I made a sensor which gives me the relative sun angle to my window using the azimuth of the sun and then subtracting 50 degrees from that, so that gives me the angle relative to the window. But what I have now is basically the stepper motor that will angle the slats, changes its position depending on the relative angle of the sun to the window. There are some other criteria as well. One is that I mustn't rotate the slats while they're fully open. The slats need to be closed across the window before you can rotate them, otherwise it just breaks the blind. So currently the controller looks like this. Well, I won't be putting it on the wall like that, it will go in a little box. So essentially I've got a 12 volt power supply and then a 12 volt to 5 volt buck converter, DC converter, call it what you will, which is giving me 5 volts, which is what I'm using to power the ESP32. And then I have 2 TMC2208 stepper modules. Home Assistant platform is only for some other module, I can't remember now by default, but these are drop-in replacements. The only thing you have to do is that the default driver that they use has a sleep pin and this has an enable pin, or it might be the other way around. Anyway, in the configuration you just invert that pin. So 2 of those stepper drivers connected, being controlled by the ESP32. I've got these push buttons which I'm using to simulate the end stops, and then I've got a little LED there which will be a fault light, so when it goes to home the blinds it knows the maximum number of steps that it could move. So if the end stop doesn't trigger before it's reached that number of steps, then the thing will go into fault condition. This LED will light up and further movement of the steppers will be prevented until the blinds have been successfully homed, so that it's got a datum point, and it will home every day at sunset. Basically that's when it closes the blinds and the slats, and if this fault flag gets set, then the LED will light and further movement of the blinds will be prevented, so I can go away on holiday happy in the knowledge that nothing's going to catch fire or do anything silly. So this is something that when I've been looking at Home Assistant YouTube videos and something and so forth, this is something that information seems to be a bit sketchy, and yet in the world of 3D printing this is something that we do quite a bit, and that's setting the motor current for these drivers. The information that I've seen on some of the Home Assistant YouTube videos is, well, if the motor doesn't turn, try turning the current up, and if you get magic smoke, turn the current back down again, which isn't very scientific. So there is a better way of doing it. And if we just look at the spec for the TMC228 driver, we can see how to do it there. You need to know the maximum rated current of the motor, and these motors came off my 3D printer. They're rated at 2 amps, that's what I'm going to use. But that's 2 amps peak, and what we really need is the RMS value, which is root mean squared. Don't worry about it, but basically it's the peak value divided by 1.41. So the maximum RMS current that we can use with these motors is 2 divided by 1.41, which is 1.42 amps. And to be safe, we don't really want to drive the motors at their maximum rating. So to be safe, generally use a value of somewhere around 80% of their maximum rating. So in this case I'm going to have 1.42 times 0.8, which is 1.13 amps. And that's going to give me the maximum torque for the motors whilst still being safe. And so nothing's going to get too hot, and if I need more torque than that, I know I need to use a bigger motor. There's no point in trying to wind the current up any further. To set the current, again you can find that information out on the TMC datasheet. But they're basically saying that the VREF, which is what we want to use, is IRMS, which is this RMS current that we want to use, which we've calculated at 1.13 amps, multiplied by 2.5 and divided by 1.77. So it's 1.13 times 2.5 divided by 1.77, which gives me 1.6 volts. So that's the reference voltage that I need to set the drivers to. And when they've been set to that, I know I'm going to get the maximum safe torque that I can out of the driver, but at the same time neither the driver nor the motor are going to overheat. So that's how we do the calculation, and now we'll move on to how you actually set it physically. So once you've determined physically what current you need to set it to, then basically it's that little trim pot there, which I'll try and zoom in on. That's the trim pot that needs to be adjusted. Now you can measure the voltage two ways. One way, I'll bring my meter into shot, I'll have to zoom out a little bit, is that pad there is VREF, which is giving me 1.61 volts. So if you've got enough hands, you can put your probe on there and adjust the pot. If you're short of hands, the other thing you can do is connect the probe to your meter, to the screwdriver, because that little screw also gives you VREF. So if you haven't got quite enough hands, then you can use that method to adjust the pot to the desired value. The next thing I want to talk about is setting the number of steps that you're going to need for your application. Now again, when I've looked at home automation videos, this seems to be very hit and miss. Generally the advice seems to be think of a number and see what happens, and then alter it to suit. but we can be a little bit more scientific than that. But before we go into that too much, here's the pin out for the TMC2208 driver module that I'm using. Starting on the left, we've got ground, which is fairly obvious. Then we've got VIO, which is the IO voltage that you're using. So basically that goes to 3.3 volts on the ESP module. Then we have OB2 and OB1, which are one pair of coils on the stepper motor, and OA1 and OA2, which are the second pair of coils on the stepper motor. It's easy to identify which wires on a stepper motor are a coil pair. If you've got a multimeter, just set it to continuity and find which two wires you have continuity over, and then you'll know that that is a pair. Also, if you want to change the direction of a motor, if you wired it up and it's going the wrong way, rather than change all your code, all you have to do is swap one pair of wires. So, for example, you know OB2 and OB1, if you change them around, then the motor will run the opposite direction. So that's a stepper. Then you've got ground again, and then you've got VM, which is the motor voltage. So I'm using 12 volts in my case. These drivers run constant current, so although the motor might say on it 5 volts or something like that, you can run them at a lot higher voltage. The driver chip does all the clever stuff. Then on the other side of the chip, we've got direction and step, which go to the ESP32 module. The next three, the clock and the PDN UART, we're not using because that's for setting UART control, and I'm using ESPHome and it doesn't support UART control for these steppers, not at the moment anyway. The bottom one is enable, which I think I mentioned before, for the ESPHome integration. It uses sleep, so you still set it up using the sleep pin, but you just invert it and then it works like an enable pin. But the two pins we're interested in for setting the number of steps we're going to need are this MS1 and MS2. So if we scroll down the Big Tree information site a little bit further, we come across this, which is a choice of working mode MS1 and MS2. So basically a stepper motor has 200 steps per rev if it's a 1.8 degree motor. There are also 0.9 degree motors, but we won't. They have 400 steps per rev. But the most common ones are 1.8 degree, but 200 steps per rev. That's full steps. And if you run a motor at full steps, then it is quite noisy. So what we generally do is use micro stepping, and what that basically does is it chops each big step into a number of smaller steps. So say you wanted to move 10 full steps, if you used say 8 times micro stepping, then each of those big steps would be chopped up into 8 smaller segments, and it would send 80 smaller pulses that would equate to 10 big ones, and so the whole thing is a lot quieter. So you can see we've got a choice here. Now, generally in 3D printing, it's generally accepted that 16 times is the best kind of compromise. So for no better reason than that, that's the micro stepping that I decided to use. So you need to set these MS1 and MS2, you need to connect them to something or other. For 16 times micro stepping, which is what I've elected to use, both MS1 and MS2 will be connected to VIO. And then to the right of that we can see a thing called interpolation, and basically what that means is the driver chip itself will chop the micro steps that we set into further smaller steps to interpolate it to 256 times. So basically if we had 16 micro step, the interpolation would chop that up another 16 times to give us 256 micro steps. Basically we don't really worry about it, the driver chip does that for us. So then Once we know what the microstepping is, then we can work out for a given position that we need on our application, we can work out how many micro steps that's going to require to move whatever it is we want to move by that amount. So basically what I'm saying here is I've got 1.8 degree motors, so 4 steps per revolution, 360 degrees divided by 1.8 is 200. The micro stepping I've elected to use is 16 times. So the micro steps per revolution, and what we're going to send from our ESP to the driver chip, is going to be 3,200 for one revolution of the stepper. So in this case I want to calculate the maximum number of steps it's going to take to go from fully closed to fully open. So what I've done is I've closed the slats completely and then used an indelible marker on the pulley to see where it is, and then I've rotated the pulley with it attached to the blind until the slats have gone fully open, and that was 6.5 revolutions of the pulley. So from that I can work out that to go from fully closed to fully open will be 20,800 micro steps. So rather than just pick an arbitrary number and see what happens, you can actually calculate it. It's going to need, in my case, probably a little bit of further refinement, but this will be very close to what I'm actually going to need. So that's probably enough for this video. So I've actually got a working prototype. So I've got a stepper motor that rotates in relation to the sun angle relative to my window. So when I get it all connected up, that will rotate the slats depending on the sun angle, so that they're always at 90 degrees to the sun. There's a few other things as well. I've yet to fit a light sensor, which I'm going to do, because if it's an overcast cloudy day, then I just want the blinds to be fully open. But most of the code is written. It's doing what I want it to do. I say code. Most of the programming through ESP Home and Home Assistant, which is really easy to do. Even a 68-year-old mechanical engineer like me can just about cope with that. But that's probably enough for this video. Getting a bit long already, I'm aware. So I've got a fair bit of work to do. I've got to build a proper circuit for this. I'll just use some Veriboard or something like that to do it. And then I need to make an enclosure for it, and I need to make new mounts that are going to hold the motors and tidy the wall up and so forth. Before I can do that, then I've got to get my 3D printer back up and running, so it's all a bit chicken and egg. But in the next video I'll talk about the Home Assistant stroke ESP Home setup and explain how that all works, how everything actually gets controlled, what does what, and features like not being able to rotate the slats if the blinds are fully open, and not rotating the slats in proportion to the sun when the sun is below the horizon, and various other things that I have to think about. So till next time.